5, 4, 3, 2.
Pan camera 1.
Good evening.
What makes using computers so intriguing to humanity? From centuries ago in China, using the hibiscus, making intricate designs using looms, to decades back to one of the first modern analog computers, technology has always been a huge part of our culture, and is still drastically improving every day.
It's one small step for man, one giant leap for mankind.
Flash forward to 2019, and it's taken the world by storm, with billions of people every day using their phones or computers to do anything from talking to friends and family, to shopping online, or even doing work. It's no wonder why there's been a huge adoption in the recent years towards this newer technology. We all use these technologies, but we don't really know how they work, how they become what they are, and the people that work with them. And for the past months, I have been researching and assembling all kinds of data and information to get a first-hand look at computer engineering and what goes beyond. History. We start off with computer engineering and what it is. Let's break it down. We start with computers. So what are computers? Computers are machines that process information to perform tasks. And an engineer is defined as a person who designs, builds, or maintains engines, machines, or public works. Put together, they form a person who designs, builds, or maintains the way the computers are and how they process information for tasks. Before we start using computers, we gotta go back to when computers were first made and used and how they have changed over time into what we have today. The first computers weren't digital or electronical, but rather were physical tools used to assist people back then. Common uses were as of arithmetic, such as the hibiscus, boards with movable pieces, and later on looms. Looms allowed the use of punch cards to insert designs rather than each thread being changed manually. The ability for a machine to perform actions was then realized and was later on improved to perform basic arithmetic. The first modern analog computer was invented by Sir William Thomson in 1872. Like mentioned earlier, there's a common thought on how computer engineers are merely the hackers of society. Purdue University Office of Future Engineers lists some myths regarding the field of engineering, quoting how engineers sit at the computer all day or don't work on significant projects. These ideas indeed apply to computer engineering as well, and have been ingrained over time through different mediums, simply associating IT technicians, programmers, and such to simply just know how to do everything on a computer, such as knowing how to repair them with ease, or make something that will do what they want them to do, like with code. These mediums being social media or other forms of entertainments like on TV or in movies. Although this is true, computer engineering is merely an umbrella term for the many fields and specializations that focus on things like hardware or software and are more than simple coding or maintaining them. The US Department of Labor and Statistics lists some specializations as such. Hardware and computer architecture increase overall system performances for businesses and organizations that utilize computers and computer networks. Individuals who are within this field are usually in high demand within businesses that extensively use technology on a daily and want to maximize performance within. Computer communications and networks refer to the transfer of data between two or more computers. Connections between networks computing devices is either cable media or wireless media. A really good example of computing network is the internet. It is a lot of computers connected sharing data. Computer network specialists design, monitor, and maintain and fix computer systems, networks of all sizes. Cybersecurity refers to the process and practices designed to protect our technologies from others that should not have access to them. The use of such can range from small businesses to major corporations or even governments, since each of these store sensitive data in computers. Since the data processed by these organizations are of high value, the risk of others wanting them increase and are susceptible to attacks, which is why cybersecurity is very important in the age of technology we live in. In addition, the software side of computer engineering has benefited society for many practical uses that you may not fully be aware of. Public projects like wastewater systems, professional tools such as law enforcement and pharmaceuticals, and personal leisure with music, email, and video gaming systems are all based on software code via computer language. As a student pursuing a related degree, an abundant amount of options and focuses allow for a very flexible, knowledgeable career. These types of engineerings are doing much more than sitting in front of computers, but rather using their knowledge in order to create, develop, and expand new ideas in order to benefit society. Computer engineering isn't computer science, although many people think it is and often interchange these two words. Even if both are related to computers, they are not the same, though they still have similar ideas. According to the US Bureau of Labor Statistics, computer engineers research, design, develop, and test computer systems and components such as processors, circuit boards, memory devices, networks, and routers. The University of Maryland describes computer science as the study of computers and computational systems, mainly focusing on software-based disciplines such as artificial intelligence, graphics, or bioinformatics. Degree plans in college also differ between engineering and science, such as in UTRGV. The degree plan is similar, but with different paths. Computer engineering to me is somewhat like getting a minor in computer science and a minor in electrical engineering. Within the formal engineering pathway, there are 3 options that can be taken: general, software, or hardware. The scientific route focuses mainly on the software side of things. In general, they all have the need to improve what is already done. They all carefully distinguish what is the highest priority to fix. They then attack the problem, and if it's not resolved, will try again until solved. In a way, they are not so different at all, but like mentioned, focus on macro versus micro problems. Rather than the purpose of what this video is for, I would like to start with why I did this for me. I started researching this to not help inform my audience, but to inform myself. I was unfamiliar with what I was getting myself into, but after gathering sources, I've learned the different paths within that appeal to everyone's preferences. I decided to focus heavily on the software side, but still have knowledge on the hardware side. Mainly deal with computer architecture or something like that deals in that area. With this at hand, the mass majority is not aware of what computer engineers truly do. Throughout this video, we have talked about a handful of misconceptions associated with, as well as what they really do in their fields. We touched on how the fields of computer engineering and its scientific counterpart are not the same thing, in contrast to what society thinks. Hopefully, after watching this video, you may have learned something new, or this may have cleared up any misconceptions you had with the computer engineering as a whole.